Okay, number 5. So they want us to graph r equals 2 minus 4 cosine theta. So we want to use this property where we can fit a cosine bx minus c plus d. And when we graph this, A is amplitude, B helps us determine the period and the phase shift, C helps us determine this phase shift, and D determines the vertical. So if we look at this equation and how we can move it to this format, we would need to move the cosine in front. So we could do 4, it's going to be a negative 4 cosine theta plus 2. Now it's in this format, right? So A would be negative 4. Since we have cosine theta, that means that B is 1 and C would be 0 because there's nothing being subtracted from theta here. And then here we've got an plus 2, so D is equal to 2. So if you remember, we find the amplitude by taking the absolute, so it would be equal to positive 4. And then the period equals 2 pi over B, which just equals 2 pi since B is 1. The phase shift equals C over B, and since C is equal to 0, phase shift's equal to 0. And then for the vertical shift, vertical equals to D, so that equals to 2. So now we can start our graph. Let's draw the x and y axis. Now we know the amplitude. Oh, well, first we want to start at the shift, right? So vertical shift is 2 here, so that means we're going to start vertically 2 up from the origin of 0, 0 here. And then we've got an amplitude of 4, so that means we'll go up 1, 2, 3, 4 from where we started, and then down 1, 2, 3, 4. So these will be our amplitudes. And we know it's going to be a cosine graph, and it's negative, so it's going to start from the bottom, and then it should go up to the top of the amplitude and back down. And once it finishes one repeat, now we've reached the period of 2 pi, but we could continue drawing in either direction if we wanted. So that's how it should be.